from FMC, and our project name is Portable Health Checker Device with blood oxygen monitor. And with my project mates are Qamreen and Vaishnavi and Smita Birada. Let us go with the objectives. These are the contents of our project. The object is the main thing is our project is to reduce the burden of our the burden of the person to in this public. And this is the health checker device to use check the how well the heart is pumping oxygen throughout the patient body, and it can be applied to check the status of the patient. And it is easy to use the portable system wherever we can this wherever we can carry this one. And next to block diagram, this is our block diagram. And the first one is power supply. Here we use a step down transformer to reduce the 230 volt to 12 volt. Next is rectifier. Here we use a bridge rectifier as a, it is used for the, it is convert AC to DC. And next one is, here we are using two regulators. One is 5 volt regulator and another one is 3.3 volt regulator. For 5 volt regulator we are using LM7815 IC, and for 3.3 volt we are using 7812 IC. 7805 IC maintain the output of the voltage, and it is connected to the next 3.3 regulator. This is mainly connected to the LCD and both Arduino board. Here we use three sensors. One is blood oxygen monitor. The sensor name is called SP02 sensor. Next one is it is a heartbeat sensor. This is the check the heartbeat of a patient. And next one is temperature using thermocouple. And the these three sensors are connected to the Arduino board. And here we are using Atmega 328 microcontroller. And this one is next. It consists of the advanced RISC architecture, and mostly used in the Arduino. And next is connected to the Wi-Fi module. Here we are using the ESP8266, and that module connected to the IoT website. Here the it is connected to the doctor or a doctor, and they will suggest for our help. And next will further explain my partner Qamreen.
Okay.
Okay, so
Yeah,
here are the hardware components what we have used. So the 8 mega microcontroller, heartbeat sensor, temperature sensor, blood oxygen sensor, Wi-Fi module, LCD, diodes, PCB and breadboards, LED, transformer, voltage regulator. So coming to the first component, that is Arduino Mega. Here we are using Arduino Mega 2560. That is, it is a microcontroller board based on 8 mega 2560. It will be having 54 digital input and output pins, which like 16 analog pins and 4 UARTs, and then 16 megahertz crystal oscillator, and then there will be one USB connection for that. The difference, I would like to say the difference between Arduino Mega and Arduino UNO. In Arduino Mega there are 54 IO pins, and in Arduino UNO 14 IO pins. So we need more IO pins in our project, so we are going for Arduino Mega. And the current consumption will be like 40 milliamps, and the flash memory will be more, like it will be 256 KB for Mega, and UNO it will be 16 KB. And then the SRAM will be 8 KB, and for UNO it will be 1 KB. So we think for our project Arduino Mega will be having the more space, and we need more space for that and more IO pins. So here microcontroller at Mega 2560 we are using, which operate at the voltage of 5 volt, and then the digital input output pins will be 54. The power can be given by USB connection, or by external power supply can be given for this Arduino Mega. So coming to the power pins, like V in 5 volt, 3 volt power pins are there, and then the flashback memory of 256 KB will be present. And then coming to the communication, the Arduino Mega 2560, it will be having number of facilities for communicating with a computer or another Arduino, or like another microcontroller. We can communicate using UART, which will be a serial communication. So the programming here, in this programming of the Arduino Mega can be done by Arduino software, like normal C or C++ program can be used for this. Now next, coming to the LCD display. LCD display which we have used in our project, it is a electronic display module and find a wide range of application, like 16 cross 2 LCD display will be used in our project. uh, and then the pins of this will be ground, VCC, VEE, register, select, read and write pin, enable. Then 8-bit data pins are used, that is DB0 to DB7. And then LED plus and LED minus, that it will be for like VCC 5 volt and again like ground 0 volt. To 8 data pins will be having the command from external unit, like such as microcontroller. The microcontroller gives the commands to the LCD, that is 8-bit for communicating. And then register select, like command register, data register pins are here used, like read, write, data register, and then enable signal. Now coming next to the a Wi-Fi module, that is ESP8266 module we are using. And this Wi-Fi module will be connected to Arduino. Like we will use the software serial port, HW serial port will be available for programming and uploading the and debugging. This Wi-Fi serial transceiver module will be based on ESP8266, and it will be of small size and low cost, which makes suitable for sensor nodes. And it operates on the voltage of 3.3 volt, and it will be taking current up to uh, 250 milliamp will be current will be used. And then next component we are using is voltage transformer. The main work of voltage transformer is that we use AC voltage is current is present, AC voltage current is used in our home and workplace, and it can be easily generated at convenient voltage transform. Hence so higher voltage is then distributed. The main reason for using transforming the voltage to much higher level is that distribution of higher, like if one place is needing more high voltage, then low to high or high to low voltage can be used. So in our project we are using step down transformer. So like what is the use of step down transformer? Step down transformer is like converting high voltage to low voltage. So here the primary windings will be more, and secondary winding will be less. So step down transformer is used in our project. Now next, coming to the rectifier. Rectifier is which converts the AC to DC. We are using DC bridge rectifier in our project. So that bridge rectifier, like it is a common part of electronic power supplies which convert DC power supply is given. The like most electronic components like AC supply are given, but we need it to DC supply. So this bridge rectifier is rectifies main AC input to DC output with using the diodes we are using here now. For rectifiers, like and diodes are used for rectifiers. Total 4 diodes, D1, D2, D3 and D4 diodes are used. And then coming to voltage regulator. Voltage regulator is the thing which regulates the voltage, like it keep the voltage. If you want to constant voltage, regulates the voltage. Now in our IC 7812, one is IC 7805. It is a voltage regulator IC, and it is the series of 78XX. The last 78005 indicates that is 5 volt. It gives out 5 volt as output. There will be 3 pins for this IC: one input, ground and output. If we are giving like 12 volt output, it gives back 5 volt. 7805, 05 represent the 5 volt output. And then another pin, 7812 pin, and that 7812 IC. 7812 IC is like 78XS series. These also come for 78XS series. If we give any voltage like 24 volt, this will give us back 12 voltage, and it regulates the voltage, so it is a voltage regulator. Now coming next to the resistors. Resistor, like two terminal electronic components which is known as resistor, which resists the current. And then Then LEDs are used in this for the LEDs and capacitor, which helps in filtering, and even buzzer is used in a component. And then even potentiometer, which helps in increasing or decreasing the value of resist for controlling the resistance power. Resistance is used, and then that's it. These are and sensors, heartbeat sensor, temperature sensor, and blood oxygen meter sensor are used. Now coming to the pin diagram, this is this is the pin diagram. First, let me explain the pin diagram here. Here arrow mark, this is V1 AC supply. This is transformer, what we are using. The transformer is step down transformer, which converts the our home AC, what our home is giving 240 volt voltage, then it converts to 12-volt current, and then this current goes to this is bridge rectifier, here we can see. And this bridge rectifier does that AC to DC, and then this current will go to these both are voltage regulators, that is 12 volt and 5 volt, here we can see. Now this is our pin diagram. This is our 8 mega Arduino, and here we can see the analog pins are connected to two sensors. Here one sensor, here one sensor, here three sensors, and then this is the Wi-Fi module, and this is the LCD module, and here the pin connection are the digital and analog pins are connected, and here is the buzzer. For buzzer we need 12 volt, so we are using this 12 volt regulator. And then for this sensor we need 5 volt regulator, so 5 volt, like here this connection goes to this and this connection goes to this. So this is all about the pin diagram which we are using in the our project. Next will be continued by Smita.
Good afternoon, sir. Am I audible?
Yes, you are audible. You can go ahead.
Sir, I will go ahead with the results. This diagram shows our current project diagram. This is how it looks. And that hand is waiting for pulse monitoring system that will.
Smita,
Yes, sir.
you have to be little louder. We can't hear you. And one more thing, there is a disturbance from your side. Make sure
Yes,
that
sir.
there is no disturbance, and
Mic off.
you raise your volume. In the sense, in the setting, the volume should be high.
Okay, sir.
Qamreen, turn off your mic.
Yes sir.
Okay, sir. I'll be going ahead with the results. That hand shows the pulse rate monitoring system that is wearing in a person's left hand. It will monitor the pulse rate, and LCD screen, Arduino board. As my friend already explained about the components, these all are the components used. I will be explaining the new thing in this. That's IoT. We are using the IoT in this project for saving all our patients' information in a cloud. That's according to the developers ThinkSpeak. That is a app we are using, which we ThinkSpeak is an open source internet things application, and I stores the relative data from the things using the HTTP protocol over the internet via a local area network. ThinkSpeak enables the creation of a sensor lagging applications. Whatever sensor we are using in this project, like temperature sensor and the smoke detector and pulse rate sensor, this all information will be viewing in a LCD screen, as well as it will go to the cloud. It will be saving in a cloud. By that, doctor can see our person's health. Like if the temperature is varying or increasing, decreasing, he can suggest medicines and all. As this, I'm showing that portable patient health monitoring waves. This is the model as what the patient's health will be varying, and it will be showing on the screen. Uh, Here I created four graphs as portable patient health monitoring. One is for temperature, another is for oxygen and the pulse rate and heartbeat sensor. There are four graphs. I am giving you two graphs. It will be same like here. First point is normal, and again it goes on decreasing. And after few days, I have checked that again increasing, and 2-3 times I have checked, and it goes on like that. Sir, I can show you creation that can I share my screen with you?
What you want to show output of the project?
No, sir. The how to create the Sing Speaks app, sir. A page on that.
That you can show me during the demonstration. Now you
Okay,
continue with the
sir.
explanation. If your explanation is over, let the other student start the explanation.
Okay. Applications of this project, sir, will be explained by Vaishnavi, sir.
Okay, no problem.
Good afternoon, sir. There are applications. In this applications, this project helps us where the people don't have access of healthcare provided in the communities. This means that it reaches the small villages and certain places where hospital facilities are very less, and it will reduce the transportation problem to those needy people who wants the health checkup every 3 days. The traveling cost or traveling will be less for those people. The applications helps medical staff to give more concentration on the people who need more care during any emergency cases or accident. Even it helps to send all the medical information to the patients within time, and also record the information in their cloud, particularly during the accident or emergency situations where people can be saved by this app. Sir, it is audible.
Yes, Vaishnavi, you are audible. Go ahead.
Where people can be saved by this app by checking the blood oxygen, temperature, humidity, and etc. Let's go with the advantage of this. Um, as it is a cost very less and we can afford by the common people also, and at a time more than two parameters can be checked, such as heartbeat sensor or temperature or etc. And it is very accurate and fast, so that they can treat every patient in certain time with proper medication. Important one, it can be carried from one place to another place, as it is in our project only. It said it's a portable one with sufficient size. Let's go with the disadvantage of our project. As there is not so much of disadvantage, there are few ones. Little more size, if the more sensors are added to this gadget, then it will be a more size such that it can't be carried from one place to another place. And we are using Arduino instead of Raspberry Pi, as it will lead to a less technical. Let's go to the conclusion of our project. As I conclude that the proposed system of provided accurate and fast user, and it gives at a time, and it won't take more time to give the result of our any blood sensor or temperature reactions, etc. Using Atmega microcontroller board system features various features as well as advantage of fast processing application at high end era 2 also. As we are using Atmega microcontroller, it is fast and accurate. Atmega microcontroller transmits sense data to doctor through the internet network, and it can be created great use in the field of medical and helps the doctor to keep all the patient's records, and also he can keep a keen eye on them so that the patient can be treated very well. And internet media has been own significance, from which I have chosen microcontroller for accessing purpose system for remote places. And video will be shown from the Smita. Project demo will be shown from this method.
Sir, can I on my camera, sir?
Who is it?
It's Smita, sir.
Okay. You want to demonstrate the project?
Yes, sir.
Okay, go ahead.
Is it visible, sir? Sir, is it visible?
Yes, Smita, it is visible. Go ahead.
Sir, it is pulse rate checking, sir.
Smita,
I'm trying it on. Yes, sir.
you check your voice. There is a disturbance from your side. Make sure that while giving the explanation, there should not be any disturbance.
Sir, there is no disturbance in here, sir.
Okay, go ahead, no problem.
Sir, it's an pulse rate sensor, sir. I'm checking it on somehow. This is a on-off button, sir. This is my project, sir. This is an LCD board, and I have plugged in that switch, sir. It's on now. This is the transformer which will convert high voltage to low voltage, and these are capacitors for filtering, and these are regulators. I will be measuring the temperature now. Can you see, sir? I have connected already
Yes,
to.
yes, Smita, your project is visible to us. You go ahead.
Sir, it's connecting Wi-Fi. Wi-Fi is connected with my phone with the name of demo, and this is a patient I'm checking with. This is a temperature sensor, which is my temperature right now is 29, sir. 27. It will show whether it is now I'm checking or I already saved one. I will show you. And this is the carbon monoxide I'm checking. It will be on after every 20 seconds. It will be checking continuously after 20 seconds. For that, I have used this system, sir, where it will measure the countdowns till 20 seconds. It's off now. After 20 seconds, again it will show the measurements. Sir, it's uploading now. My data is uploading on ThinkSpeaks app. This is a free one, sir. For students, 4 students can access this. Sir, I have logged in here. We can make our account here. I made it as Tulsi by the name of Tulsi, and we can also create a new channels here. I have those pages screenshots where I can increase that temperature sensor and all. If I am using more than one sensor, I can make another sensors column there. I'm updating my old data. I have been checking frequently for this demo. Now whatever I checked, that was 29 degrees Celsius. So this is again I'm updating that information on my IoT cloud. Whatever information I'm sending, which will go to the cloud, and again it will come back and save here. That it will show about a minute ago. I have checked my temperature about a minute ago. It is already uploaded here. Okay, sir. My temperature was 29.35 degree, 28.35 degrees Celsius, and this is the oxygen carbon monoxide level, by which we can know our oxygen level, which is also just now updated, August 19, and this was 237 degrees Celsius. 37 it was. And sir, one more thing I forgot to say. This is an carbon monoxide meter, which will be measuring the carbon monoxide around us. If I smoke, if I give any external smoke there, it will measure. And after 400, if it exceeds more than 400, this is the LED which will be beeping, and a buzzer for beeping that patient is in danger. It will show by that. Uh, by switching on this, if Wi-Fi is connected, it will go there. LED will be on. This is my Wi-Fi model, which is already connected by the name of demo, which it is connected in my own cell phone. That's why I can show you. But it shows here that Wi-Fi is connected, and after connecting, it is showing here 3 minutes ago. I can again upload and show you the data. It's below 400. That's why it's not beeping, sir. Okay, sir. That's it. That's my project.
Vaishnavi, go to the block diagram. Qamreen, go to the block diagram.
Yes, sir.
Now questions to Vaishnavi.
Yes, sir.
Sir, I need to open this presentation.
Okay. Do it. See, which microcontroller are you using here?
Or
Vaishnavi?
Atmega Arduino Atmega 2560, sir.
So why external Wi-Fi model are you using here?
For connection of IoT websites to the microcontroller.
See, can you say that how many pins are available on Atmega Arduino UNO? Arduino, how many total pins are available?
Pins, sir.
How many total pins?
Sir, there will be 54 digital and input output pins, sir, which are 14 will be PWM outputs and 16 will be analog inputs, sir, and 4 UART, that is hardware serial ports, and 16 megahertz crystal oscillator will be given to it.
Total pins,
And
tell me, including all
54
analog and digital.
54 digital, sir,
54.
analog will be digital pins input and output will be 54, sir.
54.
And yes, sir. Analog pins will be 16, sir.
Total pin available ಇರೋದಾದ್ರ ಮೇಲೆ 14. Where you got that 54 then?
Sir, digital input pins will be 50, out of which 14 provided PWM output, sir.
See, even though you are connecting that Wi-Fi model, what is the model name of that Wi-Fi?
Yes, sir.
Vaishnavi, what is the model? Wi-Fi module is there, no? What is the model of model number of that?
ESP 8266 Wi-Fi model, sir.
See, even though if you use that node MCU 82566, no, they will get the same feature itself. So it could be, again, it reduces the entire size of that microcontroller, and even though that can also reduces the Wi-Fi model connection because it has inbuilt itself.
Yes, sir.
Okay, so can you explain about blood oxygen meter? What sensor, what kind of sensor it has?
In blood oxygen
meter.
Okay, sir.
How it detects the blood oxygen?
So when the when we connect when it is connected to our hand, or then by the pulse rate of our body, sir. The flow of pulse rate in the body, the blood will be flowing in the pulse rate, sir, so that it will calculate from the blood pulse, and then it will show in the blood oxygen meter.
Can you say that what is the unit for that?
Blood
That
oxygen.
oxygen meter, huh? So this much of unit is required to, for a healthy person or something.
Yes.
Huh.
Like that, sir.
Hmm. Swati, next question is the same question is to Swati. Huh?
Yes, yes,
Huh.
yes.
What is the unit to measure that blood oxygen meter,
Yes,
and
sir.
what could be the standard value of the blood oxygen meters?
Yes, sir. Means it will check the how it blood oxygen is flowing through the body, sir.
Hmm.
Yes, here we are using a SP02 sensor, sir. It will check and it will show. It will store in the microcontroller Arduino,
Hmm.
and through the Wi-Fi module, it will go. It will send the message to IoT website, sir.
Okay. Can you say that something about
Yes, sir.
heartbeat sensor? How it works? What are the working principle of this heartbeat sensor?
Yeah. Hello.
Swati, the question is over to you only.
Yeah, yes, sir.
Uh, Heartbeat sensor.
Yes, sir. Heartbeat sensor means it will check the heartbeat pulse, how it works. Means how it is pumping the blood
Yeah, that is true.
heart.
That is true. Heartbeat sensor has to sense the heartbeat. But my question is how
Yes.
it works, on what principle it works. Smita,
So,
no. This question is only for Swati and Smita now.
Sir,
Vaishnavi, uh,
in normal person, that oxygen level is 75 to 100, sir. If it keeps varying from 95 to 100, sir, per milliliter, if blood is 6 liters in a person, it will be measured in a milliliters oxygen level. That's if it is varying from 95 to 100, he is normal. If it decreases from below 90, then patient is considered as a below oxygen level. And that sensor, sir, whatever you asked about, that heart rate sensor is, it is based on the principle of it measures the change in the volume of the blood through the origin of the blood, which causes the change in a light instantly, origin, sir. That sensor is on a fingertip, sir. If I keep a finger on that, it will be measuring my pulses, sir. That small chip, sir, will measure my pulse rate. By that, if it is it will measure that, sir. As it is painless one, that's why we are not cutting it and taking a blood and measuring by that. Oh, we are only measuring by putting the finger on that sensor, sir.
okay. Qamreen, can you say something about the temperature sensor? What kind of temperature sensor it is, how it works?
Yes, sir. Hello. Yes, sir. Hello. Am I visible? Audible, sir?
Just go ahead.
Yes, sir. Temperature sensor, it is used like amount of heat, how much heat will be produced by our what we place hand or finger or any metal. With that, like it senses the temperature and it gives back the output. Like there will be three pins present there, like input, output, and then the ground. Like if we give the input, like I place my hand on that, it senses my heat energy, like how much heat energy it is
Qamreen,
producing. And
please understand my question. Just I would like to know the working principle of temperature sensor. That's all.
uh,
What kind of
like
sensor it is, and what is the working principle of that?
on heat energy, it will be working. So like.
ಈಗ heat change ಆದ್ಮೇಲೆ at least it's going to be make the sense, no? And what principle is going to be senses? Whether it is a
Uh,
thermistor or what?
no, sir. Like a diode.
Qamreen, please try to understand my question.
Yes, sir.
It is not a diode. Diode cannot sense temperature,
Uh, so one more time, please explain me the question. I'll
My
listen.
question is very simple, straight. The question is, what is the working principle of temperature sensor here? That's all.
Uh,
Huh.
yeah. So like volt, so, like voltage increases, so voltage drop with that.
See, you are not providing any voltage to that right now, isn't it? Simply you are, touching
Hello.
that sensor, it giving the readings. That is fine. But what is the working
Yes,
principle behind
yes,
that?
sir.
Just by holding the sensor, how it's going to be sense the temperature of our body? What kind of principle is involved to measure the temperature of the human?
Uh, so
Okay, no problem.
yes, sir.
Qamreen,
Yes, sir.
go to the next slide where you have a pin connection.
Yes, sir.
Okay, can you enlarge it?
Yes, sir.
Everybody is there?
Yes, yes, sir.
Smita,
Yes, sir.
can you explain the working of full wave bridge rectifier circuit is there, no?
Yes, sir.
Explain the working of that. During positive half cycle, which two diodes will conduct, which two diodes will remain off. During negative half cycle, which two diodes will conduct. Show me the working path in that one. You first tell me
Sir.
whether you can see that full wave bridge rectifier from this slide.
Yes, I can see that. I can see, sir.
Yes. Okay, go ahead. Go ahead.
Sir, this is connected from that step down my transformer, sir, where the direct current is cut down to 12 volt, and that is given to bridge rectifier. In
Okay.
uh, l- the proper bridge rectifier is selected,
One
sir.
second. Smita, 1 second. Qamreen, Swati, and Vaishnavi.
Yes,
Yes,
sir.
sir.
Can you mute
Sir.
your microphone?
Okay.
Yes, sir.
Yes, sir.
After Smita's is over, I will come back to you one by one. Let Smita complete her answer.
Bridge rectifier is a common part of electronic circuit, sir, with DC power supply for supplying the various electronic based components. Um, uh, it takes a AC main supply input and gives the output as a DC supply. It is in a bridge connection, sir. Uh,
Smita,
So it is connected like D1, D2, D3, D4, where D1, if I draw this manually, D1 and D2 will come in serial, like one after another, and D In this case, diode D1 and D3 and D2, D4 are input supplied, sir. In
Smita,
D1 and D3 are in forward bias, and in first half, sir, D1 and D3 are in forward bias, and D2 and D4 will.
Smita, can you draw this diagram of current flow for the positive
Yes,
half
sir.
cycle in a piece of paper and show it to me?
I can, sir. Just a minute.
Yes. During positive half cycle, how current flows and completes the path using which two diodes, and draw the output waveform. What is the input waveform? What is the output waveform? Same thing you have to do it for the negative half cycle also.
Sir, this is my circuit diagram, sir.
I can't see your diagram, Smita.
Is it visible, sir?
No, you do one thing, turn off the camera and turn it on again.
Is it visible, sir?
No, no, not yet. I can't see you, Smita. Qamreen, Vaishnavi, and Swati.
Yes, sir.
You three at the same time, you also take a piece of paper, draw the input waveform. During positive half cycle, which two diode will conduct and what will be the output? And during
Yes, sir.
negative half cycle, which two diodes will conduct and what will be the waveform? You also write it in a piece of paper. When I come back to you, you have to show me that paper and you have to tell the working.
Okay, sir.
Smita, you continue.
Sir, is it visible?
No, Smita, not yet. Smita, turn it off and turn it on again.
Sir, is it visible now?
No, Smita, it is not visible.
Sir, can I connect again back?
Okay, no problem. You can do that. Qamreen, Swati, and Vaishnavi.
Yes, sir.
Do it in a 2 minutes.
Okay, okay, sir.
Yes, sir.
You have only 2 minutes. Within that
Yes, sir.
2 minutes
sir.
only, you have to complete and show me.
Yes, sir.
Yes, sir.
Sir, is it visible now?
Smita, Birada, no. You are not visible yet.
Sir, actually, Qamreen is presenting. That's why I'm not visible. Stop presenting, Qamreen.
No, that is not the issue. Okay, now you are visible, Smita.
Oh.
You hold that paper in front of the camera and explain me. I can see you, Smita. You can go ahead.
Yes, sir. Now, sir.
Yes, yes, go ahead.
Sir, this is my circuit diagram, sir.
Okay.
Here I'm connecting it from transformer, sir.
Okay.
It's a step down transformer. That's why here are more windings and here are less windings, sir. This is
Okay.
connected here. And in positive half cycle, D1
Show me the D1 from your figure. Which diode is D1 in your case?
D1, D2,
Okay.
D3, D4, sir.
Okay. Show me the path.
In forward biasing, sir, in AC supply, this is like this, sir. This is my DC diagram, sir. And in forward direction, D2 and D4 are in forward direction, sir.
Show me how it is. Show me the current flow. What happened, Smita? Can't you explain?
No, sir. In forward direction, sir, this is the D2 and D4 are in forward direction, sir. First half.
Which two diodes are forward biased?
D2 and D4 are, sir. These are in forward bias, sir.
Show me the path, how the current flows from D2 to D4, then it comes back. Okay, leave it. You turn off your microphone. Swati, Wali,
Yes, sir.
you explain me the working of that full wave bridge rectifier with
Okay,
the
sir.
diagram, whatever you have drawn.
So, yes, this is the block diagram, sir.
Okay.
This is the my block diagram.
Okay.
D1,
Okay, go ahead,
D3.
go ahead.
Okay, sir. D1, D2, D3, D4, and for positive half cycle, D1 and D3 as at the top, sir. D1 and D3. So, yeah.
Okay.
Hello.
Continue.
Yes, sir. For negative half cycle, the D2 and D4 are at negative half cycles.
Okay. What will be the output waveform? Can you show me the output waveform with respect to input waveform?
Okay, sir. So this is the sir.
Yes.
This is
Yes. Yes, Swati,
yes, sir.
I can hear you.
This is yes, sir. This is the output of the.
Why you have shown the cycles in the negative half cycle? Output you have shown in the negative half cycle, isn't it?
Yes, sir.
During negative half cycles, there will be output.
Yeah. No, sir.
Uh,
It will go got that zero. Sir.
Swati, listen to me.
Yes,
During the positive half cycle of the input waveform, what will be the output?
this one is.
Output is?
This one is.
This one in
D1
the
and D3 forward for forward bias.
leave about the diodes. What will be the output? Output waveform, will it be same as that of input waveform? Output is
No,
0, or will it be opposite of the input waveform?
Yes, sir. This is the output.
That is what I am asking. See, I can't see your diagram clearly. So that's why I am asking you, during
Yes,
the
sir.
positive half cycle of the input waveform,
Yes,
what
sir.
is the output waveform?
This is sine waves. Like this.
Like this in the sense you tell me in terms of words. Okay, Swati, you turn off your microphone.
Okay.
Vaishnavi,
Yes, sir.
okay, you show me the diagram with the explanation.
Okay, sir. So this is a diagram.
I can't see you, Vaishnavi.
Yes, sir. Yes. Can you see the diagram, sir?
No, no, no.
Sir, shall I explain by?
Okay,
Shall I
no
explain?
problem. Okay, continue.
So as D1 and D3 will be in positive cycle, D1 and D3 will be there, sir. The output
Okay,
will be in the positive, sir. Negative will be vanish. That will be zero, sir. Only positive one will be in the output of the positive cycle, sir.
okay,
When we come to the negative cycle, the D2 and D4 will be working, sir.
okay,
Even in this case, the negative will be vanished. Only positive one will be there, sir. At the end of the
okay,
full rectifier, we'll get only positive one, sir. Negative one will be zero, sir.
okay,
Yes, sir.
okay. What is the efficiency of this rectifier?
Um,
How much is the efficiency of this full wave bridge rectifier?
9.
What is the ripple? What is the value of ripple factor of this rectifier?
Ripple factor, sir.
Yes. You tell me the value of efficiency and ripple factor of this rectifier. Qamreen. Qamreen.
So full wave rectifier ripple factor will be 0.48, sir.
Okay. Is it
And
with filter or without filter?
uh, with filter, sir.
With filter. How much in without filter?
Without without filter, it will be 1.2.
Are you sure? Without filter, will it be 1.2?
No, sir.
Qamreen, are you there?
Yes, sir.
Tell me the efficiency value and ripple factor of whatever the full wave bridge rectifier you have used in your project.
81.12 will be the efficiency, sir.
1 point
81%, like around there, sir. 1 2.
81% is the efficiency.
Yes, sir.
Okay. Then how much will be the ripple factor?
Ripple factor will be like 0.48 around there, sir.
Is it with filter or without filter?
With filter, sir.
With filter. How about without filter?
Yes. Without filter around
Can anybody tell me what is the expression for finding the ripple factor?
yes, sir. Yes, sir.
With filter?
It will be like gamma equal to
under root of VRMS divided by VDC
minus 1.
So that is effective AC components by DC components, sir. Ripple factor.
No, this is without rectifier. I am asking you about with rectifier expression.
So
With rectifier. With rectifier ripple factor formula. Okay, no problem. All of you can leave the meeting.
Okay, sir.
Thanks.
Your session is over.
Okay, sir. Thank you, sir.